So when I say independent, what does it mean? Yes, anyone? Say B and C are independent on each other. So what does it mean in terms of dependency? It means B determines C or C determines B will not hold true, right? So this functional dependency will not exist in between these two attributes. So B and C are independent, right? So our table should have at least 3 attributes and there should be 2 independent attributes in the table. Okay. So then only MVD can arrive, right? So any doubt in this part? Okay. So let us discuss one example, this one. So if you go to the by definition of MVD, here you can see let R be a relation schema and where alpha and beta subset of R, then multiple dependency will hold for all pairs for tuple T1 and T2 such that T1 alpha equals to T2 alpha. If in the table T1 alpha equals to T2 alpha is present, then there should exist T3 and T4 which will satisfy this condition, right? So if you have watched the lecture, so I discuss one more thing, like by definition of MVD, like we have 3 attributes, say A, B, C. Okay, I am considering this as A, this as B, and this as C. Right. So if I want to check whether MVD is present in the table or not, say A multi-determine B here, that is S then multi-determine course. So what I can do, I have to take the same alpha value, that is A value, and I can take any 2 beta value, right? So I will take these 2. So let us say this one is T1, this one is T2, right? Now I can exchange the beta value, that is B value here. So what I will get here, that is David, Java, MKC 503, right? And here what I will get, David, Python, SN Joseph 505. Now these 2 tuples which I got by replacing the beta value, means B value, but not replacing, by exchanging the B value, is it present in the original table, in the parent table? Let us see. DJ, like David, Java. Here you can see David, Java, MKSing 503. So this one is present. David, Python, SN Joseph 505. So this one is also present. So we can say that our MVD exists. So here A multi-determine B is hold true here. Okay, you can check for other tuples also. Say we can consider this as T1 or this as T2. Okay, same thing will be there. If I interchange, instead of Python, there is Java, and here it is Python. So what I will get, David, Java, MKS 503, and here David, Python, MKS 503. Right now, David, Python, MKS 503. Yes, here you can see this is present, and David, Java, MKS 503. This is also present, right? So you just need to take any 2 tuples such that alpha 1 of t equals to alpha 2 of t. Okay, sorry, t1 of alpha equals to t2 of alpha, such that t1 of alpha equals to t2 of alpha, and then just exchange the beta value, that is b value. Okay, and if we are getting the tuples which is present in the original table, in the parent table, then we can say that MVD exists. Okay, any doubt in this part, like what I have explained here? Hello, am I audible, right?
Yes, sir.
Yeah.
Yes.
Okay. So yeah. So why in the definition why I said that there must be at least 2 independent attributes? Yes, anyone?
No, I did not get the question.
Like in the definition, I have discussed that there must be 2 independent attributes, right? It should have at least 3 attributes, and any 2 attributes must be independent. Independent means the function dependency should not exist between them. Yeah. Okay, in the same table, what if I add SID here? Say S01, S02, S03, S04. This is the role SID and S name can be same, right? Now tell me whether the MVD exists in the table or not. You can apply those four conditions also, or whatever I have explained right now. Just exchange the tuple, a beta value. We are getting the same or not. We have to check that. So let us check for S name determine course. Determine course. Now let us take this one as G1 and this one as G2. Now if I exchange this Python and Java, this one is Java and this one is Python. So what I will get? S01 David, sorry, 01 David, Java, MKS 503, MKS 503. And here S02 David, Python, SN Joseph 505. Now these two tuples are present in my original table.
No, sir.
No, because here SID is a key of this particular table, right?
This SID is a new key inserted. No, that
Yeah.
it doesn't have any relation like student, course, nothing. It is just a serial number kind of thing.
Yeah, SID, yes. You can see this as a say roll number also for student, SID, student ID.
Student roll number, but particular to that course only.
Yeah.
Okay. Okay.
So MVD exists here or not?
Well,
No.
it will not exist because it is all unique then.
Yeah. So if you see this condition like T4R minus beta equals to T2R minus beta or T3R minus beta equals to T2R minus beta. So if I consider this as T1, T2, T3, T4. So yeah. T4 R minus beta. So my R is this whole attribute and beta is course here. So SID David, which yeah. So T1 equals to T4. Yeah. So R minus beta is you just skip this beta part. Now see S01 David MK Singh 503, S04 David MK Singh 503. Is it equal? No, right? Because this SID is unique for this David, right?
Yes.
Yeah. So this condition will not satisfy. So both the case will not satisfy, right? Okay. Now let us check for this. Let us solve for this question. Okay. So course multi-determine institute room or STM exist here. You can apply those four conditions also, or you can simply exchange the beta side, right hand side, and see whether that same tuple exists in the table or not. Let us take Python and Python. This one is course, right? So this is our alpha and this is our complete beta. Now, if I interchange this MK Singh 503, SN Joseph 505, oh, sorry, S name is here, right? Will MVD hold here, exist here? No, instructor room is, yeah. Instructor room and S name we have to consider.
Instructor room is name.
Hello, sir.
Yes.
Do we consider the two attributes given on the right hand side as pairs to be equal?
Yeah.
Means their pair should be equal, right?
This
Together.
complete, yeah. Pair should be equal.
Yeah, means like for example, in course and instructor, we have no, for in instructor and instructor room, we have MK Singh 503 as a pair, which is same in the table.
Yeah.
And then SN Joseph and 505 is a pair.
Right. Yeah.
So is that the
Oh, no.
condition for an
No. Instructor room S name is the combination of David 503, David 505. Just consider this David 505, and David 503. Like for course instructor, this combine Python mkasing, Java SN Joseph, Python SN Joseph, Java mkasing. So this combine is a beta here. Okay, you need to check for the condition like T1 R minus beta equals to T2 R minus beta or not. You can check any of these conditions, whether you can go for this 4 conditions or simply what I have explained. Just exchange the beta value here.
I think it's not an MVD.
Not an MBD, why?
Sir, because for MKSing, the instructor room will be 505, which is not in the table.
So let us consider this. Okay, so you can say we have what is the required condition? Alpha 1, sorry, T1 of alpha must be equal to T2 of alpha, right? To check the MVD. So for course, you can take either Python or Java. Let us check for Python. If I replace the beta value, means beta is my institute room and S name, that is institute room and S name. So if I exchange this beta value with this tuple like David and 505, what I will get? So first I will get David, Python, MKS and 505.
I'm not able to understand this interchange of values. What do you mean when you're saying interchange of values?
Okay. Say suppose we want to check alpha multi-determine beta, right? So this is the MVD, right? Beta can be attribute or set of attribute here on the both side. So what we have to do, if we want to check whether this MVD present in the table or not, for the same alpha value, say T1 of alpha equals to T2 of alpha, we just exchange the position of beta value, right? Keeping all other attributes same. So in this case, what we have done, like say, consider this S name multi-determined course. So keeping the S name same, I can exchange any two of the value like Python or Java. So instead of Python, I can write Java here, and instead of Java, I can write Python. So just I will exchange the value, and then I will see the whatever the new tuple I will get, it is present in the original table or not. If it's there, then MVD exists.
So when we have, for example, in the question, we have beta as institute room and S name. So we are considering both as beta.
Yeah, both as beta. So we have to exchange this one value. We'll consider this also because here S name is same, right? So you may get confused. We'll also check for this third option.
Okay. I see. Fine.
So in this case, we have to exchange S beta is David and institute room for Python, right? So what I will get, David, Python, MKS, and here 505. Right now, I'll explain exchange the tuple beta from the tuple T1 to the this side, right? T2. So now what I will get, David, Python, then SN Joseph, because we are only exchanging the S name and institute room, right? So here 503. Now tell me, these two tuple exist in the original table or not? This is our original table, parents table. Python, SN Joseph, MK Singh is there, but 505 is not present, right? Room number, institute room. And here also David, Python, SN Joseph, but room number is 505, right? So these two tuples are not present in the original table. So this MVD will not exist in the table, right? Now you can check for second option also, SNAME multi-determined course. So you can take either this T1, T2, T3, like any tuple you can take. So initially we have taken this T1, T2. So what I will do, I will take this as T1 and this one as T2. Now I will keep, like, our first condition is the alpha value must be same. So alpha value is same and exchange the beta value. So beta value is here course, right? So I will exchange the course here. So what I will get, David, Python. So I just exchange the position of these two beta value. So Python, SN Joseph, SNJ 505. Right now Java will come here like David, Java, SN Joseph 505. Now whether this two new tuple that we got by exchanging the position of beta value is there in the present in the table or not? Just let us check David, Python, David Python S1 Joseph 505. Yes, it is present. David Java SN Joseph 505. This is also present. Right? You can also check for this one as T2, this one as T1, this one as T2. Just exchange. You will get Java SN Joseph 505. So here already is present. Here you will get David Python MKSing 503. So this tuple is present here also, right? So by exchanging the any beta value by keeping the alpha value same, so we are getting the same tuple, right? Which is present in the original table. So then we can say the MVD exists. Or else what you can do, you can just check for all these conditions, right? So what we are doing, just this T3 R minus beta equals T2 R minus beta, we are just checking, right? Any doubt in this problem? You can apply those 4 conditions also.
Sir, in the above question, the instructor room is a dependent attribute on instructor. Am I right, sir?
Instructor room is dependent on instructor, yes. Here you can say MKSing 503, MKSing 503.
So any multi-determining, if in the MVD, if just instructor room is given, then that won't hold without instructor.
No, if you just consider these 3 attributes, then the MVD will hold for this thing, right? If you skip this column, right? You want to ask?
Yes, sir.
Yeah, still it will hold. No? You can just check, consider this A, B, C. You can check for STM multi-determined codes also. Still it will exist.
Oh, okay. Yeah, okay, sir.
Yeah. But there should be 2 at least independent attributes, right? So what if I skip this course? Then MVD will not exist. You can check for STM instructor, STM multi-determined instructor. If I replace Amson Joseph 506, instructor replace SNJ 503 is not present, right? So this will not hold true. There must be at least 2 independent attributes in the table. Yeah, so let us check for this third option, SNAME multi-determined course and instructor. So course and instructor is a combined beta here. Now, either you can follow this condition, you can consider as T1, T2, T3, T4. I will discuss one example by using this also. But let us check for this one. Is there multi-determined course instructor or not? Now I'm just considering such T1, this one is T2, and exchanging this beta value. So with T1 and T2. So what I will get? David, Java, SN Joseph, right? This is beta hour. A course and instructor is a beta. So we have to exchange these 2 things, right? These 2 tuples. So course Java, SN Joseph, 503. And here David, Python, MKSing, 505. So these 2 tuples are present in the original table. David, Java, SN Joseph, 503 is not satisfied here, right? So David Python, MKSing, this institute room number is not present. So this MVD will also not hold true, right? If you check for this one, just anyone can tell me. Is this MVD hold true here for this table?
No, sir.
Yes, it holds.
No, sir.
No, sir.
Right. You can exchange any beta value, MKSing, SN Joseph, and see David Python, SN Joseph, but institute room will not be the same.
Yeah, 505 will not match.
Yeah.
With MKC.
Okay.
So the first option is correct. Only the second option is correct, right? This is the activity question. You can check activity. I think 6.4 is there. Yeah. Okay. So now what if I want to apply this condition, right? So for this T1, first condition should satisfy, right? T1 alpha equals to T2 alpha equals to T3 equals to T4 alpha, right? So it's not like that you have to consider the T1, T2 in the sequential order only, right? You can consider this as T1, this is T2, this is T3, this is T4. Anything you can take. But once you fix this sequence of the tuple, you have to check for all the condition, right? It is not like that for checking this condition, you are keeping the sequence like this, and for checking this condition, you are keep changing the sequence, right? It will not work. You have to fix the sequence first, and then you have to check for all the condition, right? Now let us check. Sorry. So let us check for this SM multi-determined course or not. So our first condition will satisfy, right? T1 alpha equals to T2 alpha. So this condition is satisfied. Now T3 beta equals to T1 beta. Now this one is T3 and this one is T1, right? So T3 beta equals to T1 beta, right? So this condition is not going to satisfy, right? So I need to check for I need to change the sequence also, right? So then in that case, you have to change the sequence and see whether it is satisfying or not. So this one is time consuming process. For every functional dependency, you need to check or change the tuple sequence and you need to see, right? If it is satisfying for any one of the sequence, then it is an MVD for this T1, T2, T3, T4, right? So if you refer to any external resources like any reference or any on YouTube, you will get the same. You will notice one thing, like it will follow the same pattern. You will get the same alpha value here. You will get the Python, not Python, like any beta value here in alternate fashion, and here you will get one value and having two value continuously, and then one more the same value of the tuple T1, right? So if you consider this as T1, T2, T3, T4. So if you consider this as T1, T2, T3, T4, you will observe the same pattern in every question, in every MVD for this particular sequence. You can refer to any reference book or you can watch on any YouTube video. They will consider the same sequence, right? Same pattern will follow because this pattern is made for this condition like T1, T2, T3, T4 in the sequence, right? So, but we should follow the definition of MVD. Just keep the alpha value same, like for alpha T1 of alpha equals T2 of alpha, exchange the position of beta and say whether those tuple exist in the table or not. Okay. So okay, let us check for this, like T1, T2, T3, T4. So this is satisfied. T3 beta equals to T1 beta. So T3 beta equals to T1 beta. So here you can see beta is Python, right? We are checking for this. This is alpha, this is beta. So this is alpha and this is beta. So what is that? T3 beta equals to T1 beta. So this condition is satisfied. Now T4 beta equals to T2 beta also. T4 beta equals to T2 beta. This is also satisfied. Now T3 R minus beta equals to T2 R minus beta. So T3 R minus beta. So David S and Joseph 505 is equals to T2 R minus beta. That is David S and Joseph 505. So this is also satisfied. Now fourth condition is T4 R minus beta equals to T1 R minus beta. So that is David M casing 503, David M casing 503. Right. So all the conditions are satisfied, then we can say that this MVD holds true here, right? Any doubt in this part? So there is one more rule for MVD. Say if alpha multi-determined beta exists, and I can say alpha multi-determined R minus beta also, right? So if this condition is holds true, then can you tell me another MVD for this by applying this rule? Yes, anyone? There is one more MVD here. Can you tell me?
So S name multi determines instructor and instructor room.
Yeah. So S name is our alpha. R minus beta, that is course. If we subtract course, we will get instructor and instructor room. This instructor, comma, instructor room, right? So this MVD will hold true here.
So this is happening because they are not functionally dependent, right? So we can take the complement R minus beta.
Yeah.
If course and instructor room were functionally dependent, you would have not able to do this.
No, these are dependent, right? Here you can see I'm casing S and Joseph. Yeah, these are dependent.
They together are not dependent on course.
Yeah, so these two together are not dependent on the first, right here.
Yeah.
The combination of this beta and this, so not this r minus beta and betas are independent, right?
Yes.
Yeah, so then we can say. Now, okay, so there are two MVD here, right? These two. Now, what is the condition for 4NF? It should be in VCNF and no MVD, right? So in this table, MVD is present. So we have to remove this MVD. So how should we do that? Like how to do that? How to remove this MVD? Yes, anyone? What do we do if we want to remove any redundant functional dependence, like we have seen in the normalization, right? If we want to remove partial dependency or transitive dependency, what we do?
Add another parameter.
Sorry?
Add another parameter like serial number or something.
No. Oh, that we cannot do, right? This is our table only.
Okay.
We cannot add one more table. We can simply decompose this table, right?
We can find the union between the two statements, multi-dependency statements we have written. Alpha union beta will be one table, and we can do alpha and r minus beta.
Yeah, see there are two MVD, that is S name, multi-determine instructor and room, and one more is course, right? So we can keep this in one table and we can keep this in another table. So
Yes,
my S1 will be S name and course, right? That is David Python, David Java, and my S2 will be S name instructor underscore room. So that is David MKS 503 David SN Joseph 505. Okay. So can you tell me why I have put only two tuples here in both the cases? Like why not like this David Python again and David Java again? Because for this table, this will be redundant, right?
Yes.
Two tuples, yeah.
And if you take a cross,
if we join these two tables, we'll get the same table, right? Here.
Yeah.
Because S name is same. So if we join, so David Python, it will match with the S name. David is there, MKS 503. Again, this David Python will match with this David because S name is same, right? SN Joseph 505. So we'll get this same table after joining S1 and S2, right? Okay.
Sir, what will be the primary keys of each of the table?
Primary key.
Yeah, primary key or super key.
For this table, this combination of S name and course and this S name institute and institute term will be the key. Combination of all attributes. Because there is no functional dependency in both the table, right?
In second, this instructor and instructor room has got a dependency.
Yeah, if it is only one is there, right? But can I find all the attributes from this one instructor? No, right? We should able to find all the attributes in the present table if it is a key, right? So in that case, what will happen? The combination of all the attribute, we can make it as a key. And then this two S1 and S2 is in BCNF also. For any table R, if there is no functional dependency, and we can take the we can make the combination of all the attribute as a key, then that table will be in BCNF. Because combination of all the attribute is a key here.
What I mean is that in S2, David sorry, S name plus instructor will become the primary key. No, instructor room is not required.
No, here in this case we are saying because we have only 3 tuples, right?
Right.
So what if there is David MKS and say it is 506, right? Then this is also not satisfying. Part. It depends on the condition also. Like for this condition, it is not required. But remember this: if there is no functional dependency applied to any particular relation, then we can consider this whole combination of all the attributes as a key, and then that table will be in VCNF. Okay. Okay. Any doubt in this part? This question? Yeah. Same table is there in this question also. This is also activity question. It's activity 6.4. You can check. Only SID is here, but SID we have added MV01 for all the cases, right? So if even if you take STEM multi-determined course will hold true here. Combination of SID STEM determined course will hold true here, right? You can check for any of the condition because anyway this is same, right? For all the 4 tuples. So in the previous case we have seen STEM multi-determined course. So SID STEM will be also multi-determined course. So this will exist. This is not correct because MVD is present. Okay, so STEM is, we have given STEM multi-determined course is an MVD here. Then which of the following is are correct? Can you? Yeah. Yes, anyone? Can you check for the condition? Option 3.
Yes, sir, it will exist.
It will exist, right? Instructor and instructor will exist. Yeah. Option 4.
No, sir.
SID instructor course will not exist. Yeah. So only second and third option will be true, right? This is not correct. You can check for that rule also, like if SNM multi-determined course, then SNM should determine R minus that course. So it will be SNM multi-determine SID instructor and instructor room, right? This will also exist. Okay, so here one more example. Yeah, so I'm talking about this such scenario. So which one you consider T1, T2, T3, and T4, and then check for apply those 4 conditions and see whether it's satisfying or not, right? See, if it's satisfying for a particular alpha value, DBMS, it should satisfy for a Java also, right? So according to a definition, if you read the definition, for all the pairs of tuple T1 and T2 such that T1 alpha equals to T2 alpha. If there exists 2 tuple with the same alpha value, then there exists 2 more tuple such that it should satisfy this condition, right? So for DBMS, it will satisfy. For Java, we need to check, right? For DBMS also you can check. Like how to solve this question, how to approach this, anyone? You can simply go to the option, right? Hello? Hello, hello.
So
Yeah.
here we'll exchange instructor first and check.
Yeah,
First
for
option.
this, right?
Yeah.
So for first we have to consider DBMS and then Java also, right? So let us consider this as T1 or T2. Just swap the instructors. It will be Arjun and it will be Geeta. So DBMS Arjun, DBMS beginner 3 is present. DBMS Arjun, DBMS beginner 3 is present. Yeah, this one is
Yes, it is
already present and Geeta is also present. Even if you consider this one as T1 and this one as T2, And if I take this as Geeta and this one as Arjun, so DBMS Arjun, DBMS expert 2 is present here, right?
Yes.
DBMS Geeta, DBMS beginner 3 is also present here. So for this DBM post name DBMS, that condition is satisfied. But we need to check for Java also, right? Because for all tuples it should satisfy such that T1 alpha must be equal to T2 alpha, right? If only one tuple of Java is there, like don't consider this, only one tuple of Java is there, and we no need to check for the condition because there like this condition will anyway will not satisfied, right? So in that case, if for DBMS it is satisfying and Java only one tuple is there, then we can say MVD is present. But if there are one more tuple of Java, then it should satisfy these conditions also. Okay, so yeah, so let us consider any two tuple to check for this one, this course name instructor. Any two tuple you can see, like I can take this T1, T2, right? So it will be Arman. Yeah, so Java, what is Arman? Java expert 4. Java, yeah, this exists. Then Java, Rahul, Java beginner 5. Yes, this is also exists, right? You can take another tuples also, like say, even if you consider this like instructor same, and there is no point of checking because anyway it will be exist, right? No, like we can try out that also. Okay, I am considering this as T1 and this one as T2. So let's see. Anyway, it is same, right? So Java Arman, Java beginner 5 already exists in the original table. Java Arman, Java intermediate 3 is already exists in the original table. Okay, you need to check for two different beta values. Okay, if you go for the same values, it will be already present in the original table, right? Just consider two different beta values, like we have considered Rahul and Arman. So our first option is satisfying the MVD condition. So this one is present. Now course name book here, is it present?
No, sir.
Now we can consider this same thing, right?
Addition will not match if we exchange.
Yeah, T1, T2 book. No? Yeah. So this is DBMS expert. I'm just swapping this beta value, right? Book value, right? And here DBMS beginner, right? So DBMS Arjun expert 3 is present. DBMS Arjun expert is there, but addition will not match, right? So this is not an MVD. Course name addition will match. No, same condition will be applied because book name will not match. Yeah. Course name book addition will match.
Yes, sir.
Yes. We can simply apply those rule also, like course name multi-determine R minus beta. So beta is instructor here. So R minus beta will be book addition, right? So book comma addition, right? So this is true. So first and second options are true. Any doubt in this part?
In last case, we are swapping it as a pair, right? Book and addition together we are swapping.
Yeah, book and addition together we are swapping.
Okay.
So let us consider this as T1 and this one as T2. So DBMS Geeta, DBMS beginner 3, it's already present. So DBMS Geeta, I'm swapping with this DBMS expert, sorry, DBMS beginner 2. Oh, wait. I will consider this as T1, this one as T2. I will swap this pair, okay, with this one. So what I will get? DBMS Arjun, DBMS expert 2, DBMS Geeta, DBMS beginner 3. Now let us check DBMS Arjun expert 2 is present, this tuple, and DBMS Geeta, DBMS beginner addition 3 is present. Yeah, so our MVD will exist here. You can go to the definition also, or simply you can follow this 4 condition. Okay. So this 4 conditions are came from the definition only. Like say this is A, B, C. This one is A1, this one is A2, this one is B1, this one is B2, C1, C2. Now just swap the B1, B2, what you will get? Here A1, B2, C1, and here A2, B1, C2. Now, if you observe, it is same pattern, right? Oh, sorry, just A1 only. Yeah, I'm just swapping the beta value. So B2 will go up, so B2 C1 and B1 will go down. So A1, B1, C2, right? So if you see, alpha is same, right? And our T3 equals to T1 beta, right? So I'm considering this as T1, this one is T2, this one is T3, and this one is T4. Now check for this thing, T3 beta equals to T1 beta, yes, beta is satisfying. T4 beta equals T2 beta, yes, this is also satisfying. T4R minus beta, so T4R minus beta is A1 C1 is equals to T1R minus beta A1 C1, right? So by definition only we came to this condition. Okay. Any doubt in this part? Okay. So, okay, anyone solve this example? This is a practice question. Anyone try this? We need to decompose it into 4NF. Just tell me how to approach this. Like, see here in the question it is mentioned domains of all the attributes consist of atomic values. So prescription is in 1NF, right? So for 1NF condition, it should have atomic value, right? For 2NF condition, there should not be no partial dependency. For 3NF, no transitive dependency. For BCNF, left hand side B of any functional dependency must be key, right? And for 4NF, no multi-value dependency, right? And for each higher normal form, like for BCNF, the relation is in 3NF also, 2NF also, and 1NF also. For 4NF, it is in BCNF, 3NF, 2NF, and 1NF also, right? So now here we have to find out decomposition of 4NF, right? So what are the condition? It should be in BCNF, and then no MVD should present, right? So first we need to decompose it into BCNF, then check for MVD is present or not, then simply decompose based on that. Okay, let us decompose this prescription to BCNF first. How to do that? Yes, anyone? So here the attribute name is quite confusing. What I will do, I will take this as A, this is as B, C, D, E, and this one is F. A, B, C, D, E, F. Now what is this? A determine B, patient ID, that is B determine, sorry, C determine D. This is E determine F. Yeah, and this is doctor ID is A multi-determining patient ID. Yeah, this is C and this is A multi-determining medicine E, right? Okay. So this table is already in 1NF because it consists of atomic values. Now, how to decompose it into 2NF? We need to check whether there is partial dependency or not. How to check that? Yes, anyone?
First find the candidate key.
Yeah, first we have to find out the candidate key. So how to find out? Based on the functional dependency only, right? We are not
Yes.
going to consider multi-error dependency here. So what is the candidate key here? Yes, anyone? What is the candidate key here?
I think it is
A,
the
C,
entire
E.
thing. A, B, C, D, E, F.
Yeah, so we can apply one trick like if the attribute is not present on the right hand side of any functional dependency, then those attributes must be a part of candidate key, right? So here B, D, F is present. So A, C, E is not present. So A, C must be a part of candidate key, right? Let us check whether AC is candidate key or not. Now, to check that, just take the closure of this ACE. What I will get from ACE, I will get the ACE, the trivial function dependency. Then from A, I will get B, and from C, I will get D, and from E, I will get F. So AC is our primary key, right? What are the prime attributes here? What are the non-prime attributes?
A, C, E are the prime attributes.
Yeah. The attribute which present in the candidate key are the prime attribute, and remaining are non-prime attributes. So non-prime attribute are E, D, F. Now, what is the condition for 2NF? There should not be any partial dependency. So no partial dependency means what here? What is partial dependency here?
Proper subset of candidate key should not determine non-prime.
Yeah. So if alpha determines beta, and if beta is a non-prime attribute, and alpha is a subset of candidate key,
yeah,
then there exists partial dependency. Now let us check for first functional dependency. A is a proper subset of candidate key, right?
Yes.
It is determining beta, non-prime attribute.
Yes.
So we have to remove this partial dependency. Same for C and same for E also, right?
Yes, sir.
So we have to remove all the partial dependency. So what we will do, we can take the closure of left hand side of that functional dependency. So if I want to remove this A, determine B, so what I will do, I will take the closure of A. So what I will get? AB only, right?
Yeah, AB.
Yeah, if I take the closure of C, what I will get? CD only. If I take the closure of E, what I will get? EF only. Right?
Sir.
So I can make this as R1, R2, R3. So this R1, R2, R3 is in 2NF, right? Now for trivial functional dependency, like for transitive dependency, what is the condition for transitive dependency?
Determines B, B determines C.
Yeah,
determines
so non-prime attribute should not determine other non-prime attribute, right?
Yes.
So for R1, only one functional dependency is applicable, that is A determine B. So A is key here. So it is in 3NF. This one is also in 3NF. This one is also in 3NF, right? And same for BCNF also. Left hand side must be a key. For R1, only one functional dependency is there. So A determine B. So A is already key here. Same for R2 and R3. So all these three relations are in my third NF also and BCNF also, right? This is not a proper example to explain this because only one partial dependencies exist, right? So I can decompose that. So my these three relations are in BCNF also, right? And I think we have to go to the option wise here, which among the decomposition is given. Yeah. Let's see, option is there. Just 1 minute. Yeah, this is the question. So question is we have to decompose which among the decomposition is in 4NF, right? So if you observe, we get these three relations, right?
Yes, sir.
This is in BCNF also. Yeah. So doctor name, doctor, patient ID, medicine, doctor ID, patient ID, medicine. So you can see in the second option, doctor ID, patient ID, medicine is present. But doctor ID and patient ID is a MVD here, right? So this relation is not in 4NF because MVD is present here, right? You can see doctor ID, patient ID. Now let us check for option third, doctor ID, doctor name, patient ID, patient name. Here also MVD exists. This doctor ID and patient ID, right? And the fourth option also. Let me check.
The MBD is not present.
MVD is not present.
They have separated the two tables, doctor
Yeah.
ID and patient ID, and doctor ID, medicine ID.
This is not present. So which one of the decomposition is 4NF then? 1 or 3?
So fourth, right? Because it has the first options, 3 tables, and the additional 2 tables which remove the multi-value dependency.
Let us check the answer. Fourth one, right?
Sir.
Yeah, but why fourth one? Why not third one? Or what happened? Logout? Okay, just 1 minute. Those 3 relations are in BCNF, right?
Yes, sir.
But we need to remove MVD also. But
To make first 3 relations, we first made them into BCNF, and then in last 2 relations, in last 2 functional dependencies, we removed the multi-value part.
this is in this question we are talking about, but in general we didn't do that. We first decompose it into BCNF, and if any one of the in BCNF table, if this partial dependency is present, then we decompose that, right? But if you observe this, is this a lossless decomposition? Is there any common attribute between any 2 tables? Yes, anyone? See, option 1 is also in BCNF and it is in 4NF also. Option 2 is also in BCNF and 4NF also, right?
Yes, are you sharing anything? Because
Yes, yes.
it's not
Okay, I'm not
visible.
sharing. Oh, sorry, sorry. Yeah, this one. Here you can see first option. Is it a lossless decomposition?
No, sir. It's lossy because there is nothing common.
Yeah. But this one is a lossless decomposition, right?
Yes, because last 2 relations.
Yeah,
have
if you
common
take the
attributes.
R1, this R4, you will get this by functional dependency. And you can simply R1 union R3, right? You can do that. This is a lossless decomposition and no MVD is present and this enough also. So fourth option is correct.
Sir, the last table is also dependency preserving, right? This
Yeah,
last option.
dependency is preserving also, yeah.
Okay.
This one example I have explained in the week 6 session. Yeah, this one, question 10. Just watch. If no one has watched this, you can watch that video. Okay, in that video I have explained this example because this is a perfect example to decompose into second enough, third enough, BC enough. Okay, because here you can see one partial dependency is there, and transitive dependency is also there, right? And to check whether it is a key of left hand side is a key or not, we need to decompose it to BC enough. Okay, so this is a good example. You can try out this. Okay, so here once you decompose the relation in 2NF, like after removing the dependency, it will be a lossy decomposition. But to make it lossless, we add the one more table, which is the key, right? That is ABH or ABG. I think ABG is also key here, so I can add ABG also, right, to make it a lossless decomposition.
Last Saturday that you took this session? When was it?
Yeah, I have explained this question, right? I think you was also there. Saturday, week 6 session. Yeah, Saturday only. Yeah, Saturday. Yeah. Initially, we discussed this question and then we discussed the normalization part. Saturday only. Yeah. At the starting only, we have discussed this question. You can watch that video, yeah, and try out this question also. Not to the options, just consider this functional dependency and try to decompose till this. Okay, any doubt in any week 5, week 6, or any doubt if you're not able to understand week 7 practice assignment? Hello.
So, sir.
No doubt.
Sir, this MVD Armstrong's axioms are given. They are bit
Ah.
modified.
No, same will applicable as a functional dependency. Yeah, but I think one more is there. Complementation, argumentation, transitivity.
Complementations are understood, sir. This transitivity, they have done Z minus.
In functional dependency or the transitive dependencies, okay, let me share my screen. Yeah, so in functional dependency, what is transitive dependency is if A determines B and B determines C, then we can say that A determines C, right? A determines C. But in this case of functional dependency. In the case of multi-order dependency, if A multi-determine B and B multi-determine C, then it is A multi-determine B minus C, right?
C minus B, sir.
C minus B, okay. C minus B. This is the condition here. Now we can check for any of the cases. Okay, B determines C is not there. Instructor is not there. Okay, so may not be a good example. Yeah, this is a difference in transitivity property of a functional dependency and MVD, right? So here A determine B, B determine C, so we can say A determine C, but here A determine C minus D, B.
This conceptually means we are removing any common attributes that are between C and B, right? And only keeping which are ones which are in only C. VD.
Yeah.
Transitivity.
If this is a set of attribute and this also a set of attribute, yeah, so then we are only removing the attribute which is present in the C. Say for example, here C is book and edition, and B is edition and instructor, right? So C minus B will be book only, right? Yeah. Okay, any other doubt? Any other doubt? Any doubt in week 5, week 6, week 7? For quiz 2, syllabus will be from week 1 to week 8. But week 5 and week 6 are important week, so you can focus more on this. Okay. We'll wait for 5 minutes. If you have any doubt, you can ask. Otherwise, we can close the session then.
So the dependency testing algorithm was given.
Dependency preservation.
Dependency testing algorithm where we find the FIs for each relation and then take the union and find the closure set.
That is for dependency preservation, right?
So there were two algorithms given. Sir said one was exponentially time taking and one was polynomial time taking.
Yeah. So
The
like
both are same, right?
No, if you are going to take F1 union F2, so we have to find out F1 for each and every relation, right? So what if there are 4 attributes? So we need to take the combination of all the attributes. We need to find out the closure for all the attributes and see what are the dependencies we are deriving from it. From it. Okay, yes. It is
First
in-
one, sir, is understood. The second algorithm in that means sir has taken the common attributes and it's different. Can you explain that second algorithm?
Okay, let me check slides. Fine. Okay. Yeah, this one, right? This is time taking, right? This one is procedure. Because here you have to take the combination of all the attributes and take the closure and see whether which of the functional dependencies we are deriving from it, right?
Sir.
So here, if you see, we have to find out this much, right?
Yes.
And then take the union and then see whether this we are getting from the union of all the three, F1, F2, or F3. Yeah. So this one testing, right?
Yes, sir. This one.
Yeah, what we are doing.
Is this done for each alpha, right? I mean, each functional dependency, we take alpha and we do this.
Hmm.
So both of those algorithms, they give a same result, but why do we have the first algorithm? Because this one,
Which one is more easy?
this
one.
algorithm and the previous dependency testing algorithm,
Mm-hmm.
they are almost similar, right?
Similar, yes. The only time it will take more time, right? Procedure takes polynomial time instead of exponential time require a compute F rate, right?
Yes, sir.
So here what we are doing. Okay, so these two functional dependencies applicable, right? So A determine EF is not satisfying, right?
We have to check for that, which is not satisfying because
We're simply taking the closure of this BC in F1, then right. So if we take ABD and ABD closure from F2 and ACDF closure of F3, so that will give me preserves dependency, right?
yeah.
So BC determine DR1 implies R3. Yeah. So you're simply taking, okay, so this functional dependency is not getting preserved here, right? Which one is not getting preserved? Sorry, this one is getting preserved. EA is there, BCAD is there, BF is there. A determine EF is not getting preserved, right? So what we are doing, we are taking the closure of A based on this functional dependencies from I will get A, B, C, D. Then from this A, B, C, D, I will taking the closure from this R2, that is B determine F. So I will get from B, I will get F. And now by taking the closure of this D, I will get E. So I am getting A, B, C, D, E, F. So I can say A determine EF is preserved, right? Yeah, it will take less time now because here we don't need to find out the take the closure of all the combination and see whether which of the functional dependency is getting derived, because same example is there, right? You can see this one.
Sir.
Yeah. You do one thing, you solve this example by this method also, and same example by this method. You can see the difference.
Second method, we are only taking what is existing in the F, and we are
F,
using
yeah.
that to find the
Find the closure. Yeah.
need to find the F plus and F1 plus F2 plus.
Like,
Okay, sir.
Sir, I want to add some.
mhm.
Yes. So please try to decomposition preserve using exponential algorithm method, because polynomial method may not be preserved some dependency, so may not be work in polynomial. In the slides we can see 6.2. So
6.2.
yeah, 6.2. So
This one, right?
no sir, let me share my screen.
Okay. 6.2 is.
So you are asking about this polynomial algo and exponential algo, right? Someone asking.
Yes, sir.
So always try to test the decomposition using exponential algo, because polynomial algo some dependency may not works. You can see this example. So determinant is not here it is not preserved, but in exponential algo is preserved. So please try to find always in exponential algorithm. That's it.
Okay.
Yeah.
Sir, can we use the argumentation and reflexivity and those are axioms to find the dependency preservation?
Yeah, you can find, but simple method is attack closure of every attributes. Means suppose you can see that. Let me connect. So there is R A B C D, then functional dependency A determine B, B determine C determine D, and D determine E. So simple method is decomposition is R1 is AB, and R2 table is BC, and R3 is CD. So simple is take A closure, then also B closure. You have taken A closure, then B closure. In R2 table also take B closure and C closure, means combination of each attribute. Then C closure, then D closure. Then you have to see what are the dependencies directly preserved. You can see that A determined is directly preserved, B determined C is directly preserved, C determined D is also directly preserved, D determined is not directly preserved. So you have to take closure with the help of this subtable functional dependency. So if you take closure D determine C, then from C determine B, and from B determine A. So D determine A is also preserved. So you can say that. That's simple method. That's it.
So in polynomial also we can do the same thing, right? We can use the argumentation and all to find the dependencies.
Okay. Okay. Right. So exponential algo is be better.
Yeah, you can use the exams also, but it will take more time, right? You need to think about it.
Yeah, we have to think.
Yeah.
Okay. Any other question?
Hello. Am I audible? Hello.
Yes, please.
Yeah. So everyone understood MVD, right? Yes or no?
Yes, sir.
Yes, sir. So I want to ask you something. Is my screen is visible to everyone, right?
Yes, visible.
Suppose this is a table A. One AB. AC 1 DE. If we perform the select star from a natural join B, then tell me what is the output of this particular query
Get 4 tuples.
and what will that?
1 AD, 1 AE, 1 BD, 1 BE.
First tell me what are the column
A, B, and C.
A, B, and C, and what is the output?
1 AD,
1 A
D,
D,
1 AE,
1 A E, right? Hello?
1 BD,
1 B,
D.
yeah, go ahead.
1 BD,
Okay, 1 B D and
1 BE.
1 B E. So you know the MVD, if MVD exists, we decompose it into 4NF, right?
Yes, sir.
Yeah. So suppose the A,
Sorry, Pradeep, what did you say? I just lost the your sound a bit. When it is in 4, what did you say last?
when it is in 3NF and it contains the multi-value dependency, right? Then we decomposed into so that particular data is not in 4NF. To
Yes,
make it
yes.
4NF, we decomposed into the table decomposed of whichever the table has the multi-value dependency, we decompose it, right? So let me tell you what is the condition of the 4NF. It should be in BCNF. Okay, and second is
No multi-dependency.
no multiple dependency. So suppose there is one table with this particular functional dependency previously. One table AAB. So suppose this is a table, your table, assume that, right? With the functional dependency AAC, because it has a multi-value dependency or not.
Yes,
Tell
sir,
me,
it has multi-value because B
multi-value
and C are
depend.
not related.
Yeah, B or C are not related, and it has the multi-value dependency, as user said. Let's take it. So suppose this is T1, this is T2, and this is T3, and this is T4. Then it satisfy all the conditions, right? Hello.
If we swap, then it works, sir.
Then also it work, or you can check simply in this way also. Yes or no?
Yes.
Yeah, you can simply check also if you have any confusion. So let's check first condition. What is the first condition?
T1 of alpha equal to T2 of alpha.
T2 means T1A equal to
T2A,
T.
T3A, T4.
That is equal to 1, right? And the second condition is T1B
T2.
T2B equal to, tell me, equal to
A.
uh,
T.
I think here I make a mistake.
Order.
No. This is
T3.
T1B and the T3B.
T3.
Yeah. Here you can see this is T1 and this is T3, right? So A and T2B equal to T4.
T4B.
Okay. T24B, that is equal to B, and you can check this condition also. T1 T1C and the T4 T1 and the
T2. T1 and T2.
T1 and T2 should be same, right? Am I making a mistake? What is the final condition? T1 and T4 should be same.
Those tables, the tuples are written. So last two are swapped actually. You should have D, E, E, and D in the last column. In the actual tables normally.
This one.
So
Hello.
the conditions that are given, they are based on the tuples in the last column. In the middle two should be same.
Oh, okay. I think I make a mistake to. This should be AB, and this is the AB, and this is D. Okay. ABD, and this is EE. Just this should multiply with this one and this one, and again this one and this one, right?
Yes.
Okay. Right. And what is the final condition? I think I'm making somewhere mistake. Final condition is T1C equal to
T4C.
T4C should be equal to what is the previous example? I just want to Piyush sir, can you help with that? What is the previous example you just gave?
Attribute name, right?
Yeah, table names and the value, right? Correct. I just
Okay. You can take S name, course, instructor.
suppose this is the S name, this is the course, and this is instructor, right?
Yeah. In S name, all four tuples are first David, then Python, Java, Python, Java.
And this is all David, right? This is all David. Suppose this is David. Okay. Okay.
Yeah, so in the table you have make, you can,
So I just wanted to give you what is my just David. This is also David. Okay. And this one is
Python, Java, Python, Java.
okay, suppose by P.
You can simply write PJ also.
Yeah. PG and the PG. Okay. And this one
MK Singh and SN Joseph. MKS and SNJ.
MK
SNJ, SNJ.
Again
Again SNJ. Then MKS. MK.
oh, so suppose this is the A, B. So we can modify here also. Suppose this is the MK and this is SNG and this is the P and this is G. Right? Can we get this one? So first one is David. So suppose D. David, P and MK. Right? This one is the first row. Let me change my color. And this is a David, J and SNG. Okay. This is second one. And okay. And this one is the David P. Is it visible to everyone? And what I am trying to do is, so if any multi-valued exists, then we need to decompose it, right, into this format. Hello.
So 4NF.
Into 4NF. So it would be 4NF. And when we performs the natural join, it should get back to the original data.
Yes.
Right. That is our motive. So if we try, if we can do this thing, then we can say the multi-valued exist. So if any decomposed table you get, any table has the multi-valued dependency MVD has. So you can decompose in this format. Right. So that is in 4NF. And you can back to this original tables using the natural join so that it can be original, if it can get the original.
Yes.
Right. So my point is you can check also, you can decompose the tables. Suppose you can decompose this table by looking at the data, you can decompose it like two tables. Right. If you decompose these tables into two tables and perform the natural join and you get this original table, means suppose, okay, right. Hello. Yeah. Hello. Yes, Subhendu, you want to add something? Okay, just.
So if you do cross product, then you will get the original table, not natural join. So that's it.
Oh yeah. So I think I make a mistake. So if you perform the natural join, not natural join, cross product, then you have to get the original product. That's why I'm making a mistake. Okay.
No, in this case, for two tables, if you perform natural join, it will give us the original table, right?
Natural join.
Yeah, because A is same, na. So based on A, we are joining those two tables. So D will match with the one tuple, D with another table it will match, right? So we'll get the whole tuple, right?
In this case, cross join also works, but if we had more tuples with David, and some other names, then we had to do natural join.
Yeah, I think natural join.
In that case, cross join, we will have some extra tuples that will be lossy because
We do not need that. So because in we compares with the cross product, then we can say also these are equal. So that is the same thing as the natural join. So
cross product, and we can do the equal thing. Then it is fine with the condition.
Let me see. By natural join, we get this table, right?
Yes, sir.
Yeah, I think I am making mistake in this one means making the tuple T1 and the T2. What's the T2? Now I think now it is fine. T1, which
Sir,
is
now
the
it is
T1.
fine. It will work.
Yeah. So you can check with the previous example also. There is with the 7 tuple, 7 or 8 tuples are there in the one example. Just Piyush has shown you. Just showed na means one example 2. I think example 2 is that is whether exists the multi-value dependency or not. There is 8 tuples that Java beginner or like that. So you can try out, you can decompose that tables into also the 4NF also. If MVD exists, then you can decompose it into 4NF. Otherwise, you cannot do that. Yeah. Everyone got what is my point?
Pradeep, you're sorry. I mean, it might be little late to ask this question. I'm trying to understand what you are saying in terms of when we have 4 tuples. What is bothering me or what I'm not able to get the answer is, in real world, we will have tables where we will have multiple, I mean, the rows will go, the tuples will go into thousands, more than thousands, and attributes will not just be 3 or 4, it will be many, right? So what is bothering me is we see only for 4 tuples. But when you say a table, I'm not able to understand the concept. When I have a real table in front of me with thousands of tuples and hundreds of attributes, then what we will do with this MVD, how we will say that particular, will we pick up 4 rows and then do something? I'm not able to get the answer to this question anywhere. Sorry if you have explained again, I might have missed it or I might not have been able to catch it, but this is something that is bothering me.
Yeah, so during the normalization, we usually go till BCNF only, right? So this is one of the cases like where, because this is not something like we do while generating the schema of a database, right? This dependency is basically a tuple generating dependency. So okay, now you just consider this 4 tuples are there. But what if tomorrow I will add 2 more tuples in the same database, right? The same table. So in
Yes,
that case,
exactly.
MVD will get lost, right? So it's tuple generating MVD dependency. Okay, let me show you. Okay, so says for example, today I create this table in my database and I have this 4 tuple. Okay, so
this is an instance or this is the table, complete table itself?
This is complete
I mean,
table itself.
Okay, there are no more tuples than the four
Yeah, just
tuples.
consider
Okay.
this to the day one only. So I have just four tuples. So I have added
Okay.
this, right? So here MVD satisfied, right? But
Okay.
what if tomorrow I will add two more tuples, say Tom?
Yeah, exactly.
In that case, MVD will not satisfied here. So today it will get satisfied as name determined course. But tomorrow, if I add two more tuples, say Tom, for tuple it will not satisfy my condition, right? So in that case, MVD will lost, right? So this is tuple generating dependency. So as we are adding more tuple, MVD will get generated, MVD will get lost, right? So tuple
Okay.
generating dependency, yeah.
Okay.
And functional dependency are structure generated dependency. So this is MVD and this is functional dependency. So these are structure generated. Structure means schema of a database, like this relation and the attribute, right? Structure generated dependency. Let me write. And MVD is a tuple generating dependency.
So should we have MVD? Should we not have functional dependency? What should be the consideration for a table?
Yeah. So usually while doing normalization, we go till BCNF only, which is completely depend on functional dependency only, right? So there is no rule of MVD in the till BCNF. But what as we're adding more tuples in there, MVD will get generated. But if you see, okay, so this is only my complete one table. So in that case, I can say I will add one table. So maybe tomorrow my MVD will not satisfy here. But what if we are joining two tables? So table is 1 and table 2, and we are doing cross product. Okay, we need to find out some attributes, any condition. For that, we need to do the cross product only, not natural gen. We need to do the cross product only. And in that case, I will get the MVD as a resultant table, right? It's not MVD, like this particular thing, right? In the resultant table.
Yes.
MVD will be there, right?
Yeah, Piyush, whatever Piyush said, I want to add more thing. Up to the functional dependency, we try to reduce the redundancy using the functional dependency. Up to BCNF, we use the functional dependency, right? But after the BCNFs, we completely depend upon the data, whatever data present. So if any redundancy present in the data, then we remove it using the 4NF.
Yeah, so till BCNF, we generally normalize the table to avoid redundancy. But if you go for 4NF, it is tuple generating dependency based on the MVD. If you consider about 5NF, it is basically a joint dependency. So this is more of the optimization part. Like, say, suppose we decompose this one big table into 5 decomposed relation. So in what order we should join those tables in order to our query is sufficient, efficient. So that is joint dependency basically. That is 5NF. So basically till BCNF only we usually do the normalization part, but after 4NF, 5NF, these are more related to the optimization, query optimization part. Yeah, but your doubt is correct. Like if we have thousands of tuples, then it is very difficult to check such type of dependency, right? Not possible also.
Not possible.
Yeah. So this is basically tuple generating dependency. If we keep adding more rows, then our dependency will get changed, right? So what if I remove this tuple tomorrow? Then only 3 tuples are there. So in that case, my MVD will not satisfy, right?
Yes.
So this is tuple generating dependency, but functional dependency is based on the structure of a database. Yeah. So that's why we are not more concerned about MVD here. We generally do till BCNF only.
Thank you. I mean, this will help. I will have to get back to the lectures to relate more. And in case of any questions, then I'll get back.
Yes, yes.
Thank you.
Are we doing that programming practice questions also?
In the last session, we have discussed like how to structure the code, right? So that's it. You can practice it. Right? We have practice assignment also. Like it will follow the same template.
Those two practice questions.
Those two practice question you can try. See, if you see the question, like what you have discussed in the last session, you can follow the same template. You just have to change the SQL query according to the problem statement in the cursor.execute thing. And then whatever the output we required in that particular format, you just need to manipulate that using the Python, right? That's it. You have to get the input from the cursor.execute output and just do some manipulation using Python. Whatever is like output is required. Like in one of the example, we need to find the cosine of any output, right? So what I will do, I will write a SQL query to find out that particular number. Then I will take that input as a number. And by using simply converting into the using Python code, I can simply find out the cosine, right? If I get the input from the SQL query. That is a graded assignment question, right? Find out the cosine, yeah. Similarly, one question is there based on the prime jersey, right? Prime number. Yeah, practice assignment question. So you have to get the input and then you can write a Python code for checking the prime number, right? Okay, so do you need the sample solution for practice assignment question also?
That structure alone, if you can just do a brush up, that will do for me.
Yeah. Yes,
first step, we need to connect the database, then pick up the data, then do a Python this thing. Now use a Python code to take out the data.
Yeah. Okay, just 1 minute. This is practice assignment question. Yeah, this is practice assignment question. Okay, here you can see we can these parameters are given in the description only, right? You have to import this is PyPG2 module OS, then create a connection null and try to create this exception box. This what happened? See, in every question this will be the same, right? Connection string, right? And this is we have to create one cursor here, then execute the query based on the problem statement, right? So whatever the problem statement is given, you have to formulate the SQL query for that. Like in this case, if you see host team, IDs of host team whose jersey color at home is different from the jersey color when they played away from the home. Right? Here you can see the SQL query for that, right? But I'm taking the output of this SQL query in the variable rows, and I'm running the for loop on that, right? To get my required output. So what is my required output? This thing, right? Our output should be in this form where it is. This is practice question. So ID should be listed in ascending order before performing the encoding. Each line in the output program must correspond to one row retrieved from the table. So based on this thing, you need to optimize your Python code, right? If you want, you can take the screenshot of this also. You can try out your own. This practice assignment question. Hello.
Yes. I just wanted to get the flow. That's it, because I normally do not look into solutions before doing one or two tries actually, because first itself, if we look at the solutions basically, then we'll get biased by that.
Yeah, so we generally don't release because we want you to try by your own. But okay, you can take the screenshot. You can change the apply the logic also, right? You can see the output also here. Correct code. If it is 100 by 100, you can just click on the submit. You can try different logic for this. Okay, don't try this also. You can try with different logic. But this is same up till now. Up till this, everything is same. In every question, it will be same. You just need to change this cursor like a SQL query, and based on the requirement, you just need to write the Python code for that, right? Yeah, we're not going to check much Python coding here. Just whether you can apply, you can connect to a database using Python or not, and do some like small, just run a for loop and get some output. That will be the case. Similar in the case of prime jersey also, right? You need to we need to you need to fetch the output in this particular format only. So that thing you can do by using Python code, right? Yes, that's
User, just
yes.
can you again show that particular example?
Okay.
Yeah, up to
Coding.
this. No, sir, up to that.
Prime jersey, no?
Yeah, prime jersey. Please keep in mind the output format. The portal is very strict about the output in which they instructed. So you should display in that particular manner only. Otherwise, you get error.
Yeah. So here you have to find the names of player and the team of each player of all those players whose jersey number is prime number, right? So what I can do, I can write a simple select a name and team name from table name, and then I can apply the condition. But can I apply the condition like that jersey number equal to prime number in SQL? No, right? Okay, yeah. Yes, Pradeep.
Yeah, in this particular display manner, how to display the output. Here you can see the Pranav and the Amigos and the Arjun, comma, next line in Arjun, comma, all star. This is the particular display format is given to you. So you need to display in this particular manner only. Otherwise, it will show the incorrect error code.
Yeah. No comma after that, no bracket, not in one single line, just like this one.
Yeah, you can think about it is very strict about.
Yeah.
So keep it in mind.
Okay. Okay, you can try out this. Okay. I hope you have taken the screenshot of this. You can try. For every question till now, it will be same. Just need to change the SQL query and do some write some Python code logic. That's it.
Just keep it for one time. Let me take the screenshot actually.
Yeah. We can share this output on this course also, right? Okay. Cool. You can see any error in your code. If you want to debug, just you can do the print and do the test run, right? It will show the output here. Yeah. Getting graded, I will not show. Okay. Okay, any other doubt? Any other question? Okay, thank you then. We can close this session.
Thank you. Thank you.
Thank you, everyone.
Thank you. Thank you, everyone.
Thank you, sir. Thank you.